Now let's look at some equations and check if these equations represent functions. So for example, if I have f of x equals 2x plus 1, is this a function? Now this should remind you of y equals mx plus b, y equals 2x plus 1. So if you plug in an x, you get a y. Same thing here, you plug in an x and you find the value of f of x, which is really the y. So let's think about this. Is this a function? And the question is, this is the rule that associates every x with another number in the range, that is y. So every x is associated with y, and y is really equal to f of x. So the question is, can I plug in any number in for x? So for example, if I said I'm going to plug in a radical 2. So plug in a radical 2 into the function, into the equation, sorry, and we'll check if it works. So it's basically 2 radical 2, which is a perfectly well-defined number, real number, plus 1. So if I plug in a radical 2, I get 2 radical 2 plus 1. So basically, what you have to imagine, obviously you cannot plug in every single number into this equation, but just think about it. If I plugged in any real number, the next step would be, can I double it? And the answer is yes, any real number can be doubled. And what do we do next? We add a 1 to it. So basically, when you think about the rule that gives you the y when you plug in an x, is pretty straightforward. You double a number and add 1 to it. No matter which number you take, you can always double it and add 1 to it. So this tells me that every real number is associated, let's call it x, every real number x is associated with another real number (2x plus 1). So every x is associated with 2 times that number plus 1. That's the rule that defines this function. Every x can be plugged in here and the answer is exactly equal to one number. So every x is associated with exactly one y, which means you get exactly one number. Now if you think about it, let's graph this function real quick. So y equals 2x plus 1. And if it's a function, then we can write it as f of x equals 2x plus 1. So we just checked that it's a function. We checked it algebraically, thinking about what would happen if I plugged in a number, I double it, and then add 1 to it. It's always possible to do that to get exactly one answer. So every x is associated with exactly one y. Now let's find a couple of points. If I plug in an x equals 0, I get y equals 1. So 0, 1 is, let's say this is a 0, 1. That's a point on the straight line. Now, if I plug in, let's say x equals 1 into the equation, f of 1, which means I plug in an x equals 1 into the equation, is 2 times 1 plus 1. So that is 2 plus 1, which is equal to 3. So if I plug in a 1 into the equation, I get 3 as a result. So if my x is 1, then my y is 3. So let's say x is 1, y is 1, 2, and 3. Let's extend this. So 1, 2, and that's 3. 1, 3. So the 2 points are 0, 1 and 1, 3. I join these two with a line that extends forever. So this is the graph of the straight line. And now let's look at what plugging in an x means graphically in the graph. So what do I mean by plug in a number? Let's say I plug in an x into this function. And let's say I don't know the equation of this. So I plug in an x and figure out a y related to it. So if I plug in an x equals 1, I draw a line perpendicular to the x-axis until it meets this point on the graph, and then I figure out the y-coordinate associated with it, which is the height of the function or the value of the function. So when x is 1, y is 3. Same as saying if I plug in an x into this function, so I plug in an x, I get f of 1. And what is that f of 1? It is equal to 3. So here, imagine plugging in any number into this particular equation of the line. And we are doing this geometrically. I take x equals 1.5, I plug it in, and I get a value that is right here. That's like a 3.5. So if I plug in a 1.5 into the equation, I'm doing this graphically without using the algebraic equation. So plugging in means draw a perpendicular line until it intersects with the graph and then figure out the point on the y-axis at which this intersection happens. So that would be 3.5. So imagine plugging in any number into this particular function. I should be able to, no matter what the number is, I should be able to figure out a y. So plug in an x, figure out a y. Let's say I plug in this x here, a negative value. I draw a perpendicular until it meets the graph, and then I figure out the y by looking at this particular point on the graph. That gives me the y, and that would give me the x comma y. So I can do this for any number that I want. I could extend this graph more. I can say I want to plug in an x. What does plugging in mean? Go down until the graph intersects with this perpendicular line, then draw another perpendicular line to the y-axis, and for this particular x, this is the value of the function. I plug in the x to get the y. So I can do this for any number on the x-axis, right? So every x has a unique or exactly one y, because the line that I extend perpendicular line to the x-axis will intersect with this pink line at exactly one point. And that's what I mean. If I plug in an x, I get exactly one y. So this is what tells me that the graph I have is a function. So let's think about another graph that we all know. And that's a parabola. And that's what it looks like. It goes on forever. Now, if you plug in an x, you can find exactly one y for this function as well. So let's look at this. We have, and what do I mean by plug in an x? Let's say this is the function y equals f of x. I'm calling it a function because it is, but let's check if it's a function. And how do we figure that out? If I plug in an x, I get exactly one y. I plug in another x, I get exactly one y. I plug in an x, I get exactly one y. And how do I get my y? I stop when the line perpendicular that I'm drawing, the straight line drawing, perpendicular to the x-axis, intersects with the graph, and that's when I find my y, by figuring out how high the point is. That's how I evaluate my point. So when I plug in an x, I get my y here. Y is the same as f of x. So you plug in an x to get f of x, the value of f of x. So what we're really doing is drawing vertical lines through the graph and checking if the lines intersect with the graph at no more than one point. This is called the vertical line test. It's basically saying that every single x has exactly one y associated with it. Every x, exactly one y. Every x, exactly one y. And these are the y's. So this is called the vertical line test. Now let's see what a vertical line test is. If I have a graph and I want to check that it's a function, let's say my graph looks like this. Imagine drawing vertical lines through this graph. You cannot draw all possible vertical lines, but imagine drawing vertical lines through this graph at every single point on the x-axis. Notice that the line will intersect with the graph at exactly one point, which means if I plug in an x, I get exactly one y. So any vertical line drawn through the graph will not intersect with the graph at more than one point. So that tells me that every x has exactly one y and no more than one y. So this is called the vertical line test.